In this calculus problem of the day, we're going to find the area of the region bounded by the graph and the x-axis on the given interval. Let me draw a quick sketch of what's going on here. Here's the graph of our function, and on the interval from -1 to 0, that interval denotes x values, so that goes from here to here. We have this area right here of this region, and this area is what we're trying to find in this problem. Notice that this area, though, is beneath the x-axis. So when we integrate to find this area, that area is going to turn out to be negative. The integral that's going to give us this area looks like this. We're going to integrate from x equals -1 to 0. We're going to integrate the function x squared minus 40, and we're going to integrate that with respect to x. We are going to do this integration using the power rule, and the power rule says that we're going to raise the power on our variable x by 1, and then we're going to divide by that new power. As you would have seen in the last problem of the day, this 40 here can be written as 40x to the 0 power. So when we raise our power on x by 1, it becomes 40x to the first power, and then we divide that term by the power of 1. So that is our integral, and we're going to evaluate it from -1 to 0. Evaluating a definite integral means plugging this x value in right here first, subtracting, and then plugging in this lower limit of integration, this number right here for x next. This first term just turns out to be 0. This next term, I'm going to leave the negative outside. Cubing -1 gives us -1, and then multiplying 40 by -1 gives us -40, so that turns that into a plus. So the value that the integral gives us, let's see, it's going to be 40 minus 1/3. That's going to be 119 thirds, which is -39.666 repeating. And what this tells us is that our area of the region that we were looking for is, of course, the positive version of that. I'm going to call it 119 over 3 units. Or if you're looking for a decimal, you can do 39.667, depending on how many decimal places you need. So we're going to stop that there, and we'll move on to the next problem of the day tomorrow. I'll see you there.